All right, so this is from Next Time Question. This is actually one of my favorite questions in this class. So here's the problem. If you wish to save fuel and you're going to leave your cool house for a half hour or so on a very hot day, should you turn your air conditioning thermostat up a bit, turn it off altogether, or let it remain at the cool room temperature you desire? The only thing that I don't like about it is actually two things. But the main thing I don't like about it is the half hour. It's like, probably doesn't make much of a difference if there is a saving. In fact, there is. Therefore, I will instead use half a day, something like that. And as we live in Alaska, where probably don't have a cool house on a very hot day, but we rather want to have a warm house on a very cold day. So I'm going to reword the whole thing that says, if you wish to save fuel and you're going to leave your warm house for a half day or a weekend or 2 weeks or so on a very cold day, should you turn your heater thermostat down a bit, turn it off altogether, or let it remain at the warm room temperature that you desire. So as I said, I changed the prompt. Okay, the solution for that is posted as well as it always is with Next Time Questions. So here it is. This is of course the solution for the air conditioner, but the physics applies in the same way to the heater. So when it says here, in accord with Newton's law of cooling, keeping delta T high consumes more fuel. Yes, that applies to the air conditioner just as it does to the heater. When you turn your air conditioner off, you minimize both delta T and fuel consumption. The same thing would be with the heater. If you turn it down, you minimize the delta T from the inside to the outside, and therefore you save fuel. Okay, then comes the objection to that. Will more fuel be required to recool or rewarm the house when you return than would have been consumed? That's always the thing that people say, but we have to reheat the whole house. And then the answer is not at all. When you return and turn your heater back on, you extract heat at a smaller delta T. So that means, yeah, you are actually overall saving. Now, if you're not totally convinced here, and I know especially last part was a little bit wishy-washy, I'm going to have an Excel sheet coming up here, so I'm going to pause to get myself set here. All right, so I'm going to go over here. So this is the Excel sheet that I prepared. Heat loss, turn the thermostat down is the title. So room temperature, let's say it's 70 Fahrenheit. By the way, I can change any of these here. So 70 room temperature. The thermostat, if it's turned down, is 60, and the outside temperature, as I said, is cold, 10 Fahrenheit. So, oh, by the way, this is all in Fahrenheit. Either way, Fahrenheit or Celsius, I can use that. On the left-hand side, I have the number of hours, respectively. Actually, I should say over here, my time step is 4 hours. I can change that 1 hour, and if you look at the time over here, that would now go from 1 to 10 hours, with the 11th hour actually heating the house back up. Okay, but I can change the time step. So for example, I could choose 6 hours, and now you can see this here, 60 hours, which is 2.5 days. So that would be about a weekend, right? The heat loss per hour is just an arbitrary one. So it has, I take the word arbitrary back, but it's in the neighborhood of, it really doesn't have units, and it's the same no matter what. So you have a certain amount of heat loss, and I just call it 1. That's what I meant to say. Sorry about that. All right, then all this table here on the left is for when the thermostat is turned down. All this stuff on the right here is when the thermostat is left as is. So if it stays like that, it's always 70 all the way through. If you turn it down, it goes continuously down until it bottoms out, because I said, hey, 60 is the bottom, so there we go. Okay, then here is the energy to maintain the thermostat temperature. This one is the energy loss due to the delta T. And remember, this is smaller here because the temperature difference between these two is smaller. So notice the 300 throughout here mostly, while over here actually, because the temperature difference is higher from 70 to 10, it is more actually. So let's look at some chart here. So the green one here is as if you leave the thermostat like it is, And here is where you turn the heat down and it bottoms out. I guess it gets a little bit below 60. And then here is when you're not in the house. And then this one here is actually the 11th hour or so when you come back where you're reheated. Okay, the green bars are when you leave the house and the temperature is high, and you put in that amount of energy to actually keep it high because the heater still has to work in order to maintain that temperature. The orange one is when you turned it down. And notice here in the first 3 time units, you're only heating the house if the thermostat is high. If the thermostat is turned down, you're actually not heating anything. And then, yeah, this one here, then in the next hour, this one is a little bit higher because it dipped a little bit down here. But overall, throughout, after that, it's all the same. And yes, in the 11th hour, when you come back, you have to reheat the whole house. But notice that this very long bar here is actually just offset by these 2 shorter ones from when the thermostat stays the way it is. Even more dramatic is the chart. This is only to maintain the temperature, but this is the actual chart of the total energy that's lost. You can see again, I know it's different colors, but you can see again that here the temperature stays the same. Respectively, the temperature goes down, and you're hopefully you are conserving fuel. And the purple one is you leave it at a high temperature, and notice it's always high. And then this reddish one here, this is where you really save the energy because you're at a lower temperature. Okay. So overall, and this was for 6 hours at a time, so a total of 60 hours, there is an energy saving. I really have to push these out of the picture here. 3,000 energy units versus 3,600 energy units in savings of 16%. Okay, what if you're 2 weeks away? So I'm going to change this to 24 hours here, which is actually 10 days, but that's okay. Notice 12,000 heating units versus 14,000 heating units, a savings of 60%. I think we definitely can agree that, yeah, we're going to save fuel if we are really turning it down while we're gone for a long time. But notice all the way through here, yeah, there's always more if you leave the temperature at a higher, the thermostat at a higher temperature, and only in the 11th hour when you come back, that's when you have to heat the house more. But that's not nearly as much as the fuel savings you have before. Okay, what about if you only leave for half a day? So time step of 1 hour, which gives me about 10 hours here. Again, about half a day. So this one here, this is actually to maintain the temperature. So throughout the day, this actually goes all the way down here and then really bottoms out towards the end of the day. And then you come back and then the whole house has to reheat. But as it went down here, the thermostat never got on. You know, the heater, it was never heating. It was just losing heat, which means there is no orange column to heating the house. But there is a green column to heat the house if you want to leave it at a higher temperature. And again, if you look at the green bars here, they all add up to that orange bar when you come back at the lower temperature. And again, here are the energy savings. So here, purple versus red, that's the energy you would save. And yes, at the end you come back and you have a little bit more. Overall, for this short amount of time, it's only 9% of savings. So what they said in the original problem of half an hour, well, we're probably talking about pennies. But if it gets longer than that, a day, a weekend, 2 weeks, that actually adds up to quite a bit at the end. And in principle, it's always saving fuel and money and heat when you turn the thermostat down. All right, that really took me a long time to explain because this one is quite intricate. By the way, this Excel sheet is posted in Blackboard. And then, of course, I wasn't done. So just a little bit more. I can change a lot of numbers in this Excel sheet. So, for example, if I'm going to change this one here back to like a weekend, so 6 hours, and we have 16% of energy savings. So if I turn the thermostat down instead to 50, notice what happens to the energy savings at the bottom of the screen. There it is. That's actually more 30% because my temperature difference now is less, so I'm losing less heat, of course. Again, when I come back, yes, I do have to reheat the house. But that's this little thing here, this little difference. That's when I have to reheat the house. But these are my energy savings, the purple versus that reddish one there, right? I can change other numbers. So if I turn the thermostat more down, I have more energy savings. If I want to have a really balmy house, then I have also way more energy savings, 80. Okay, that was actually weird. Oh, maybe I can't go higher than 70. Okay, I should have checked that before. I guess 70 might be my top temperature anyway. If I increase this one here, so if it's not as cold, it's only 40 outside, notice actually my energy savings are really big. However, the total is not as much, because here, I mean, my house is barely heating, you know, at 50 versus the 40. But the total heating units is much less. Notice the 1,800 and 700 versus if this one is at 10 degrees Celsius, then of course I have 2,500, 3,600. No matter what, I have to use a lot of heat when it's really cold, because Newton's law of cooling and radiation and conduction, hopefully not convection, it's losing a lot of heat to the outside. Okay, now I think I'm